right, you guys. Now that we have solved quadratic equations graphically, we're going to work on solving quadratic equations algebraically. So it's just like solving any other equation, which means it is about isolating the variable by undoing the operations. Okay, and you know we undo operations by using inverse operations. And I want you guys to do a little table here where you have the operation and the inverse operation. I'll put the operation down. I want you guys to put the inverse operation. If the operation is multiplication, what's the inverse operation? If the operation is addition, what's the inverse operation? If the operation is division, and if the operation is subtraction. Okay, and then we're going to add one more on there, but I'll get to it in just a minute, and that is because it's quadratic, if we have something that's being squared, what is the inverse operation? So you might want to pause that while you fill those in, and then go back when we get to the squared inverse operation. So we're going to take the same equation, but this time we're going to solve it algebraically. Minus 10 equals 47, right? And so what I want to do though first is down here, write down what we're doing to our unknown. If x is our variable, what is the first thing we're doing? The first thing we're doing is we are adding 2, right? We take a number and we add 2 to it. So for number 1, I want you to write down we are adding 2. And then the second thing that's happening is we are squaring that, okay? So the second thing that is happening to the number, the first thing is adding 2. The second thing is we are squaring that information, okay? The third is we are multiplying by 5, okay? This means multiply by 5. And then the first thing we're doing is we are subtracting 10. Okay, so let's start that again. We're taking a number, we are adding 2, then we are squaring it, then we are multiplying by 5, and then we are subtracting 10. So to undo this, we're going to work backwards using the inverse operation. So instead of subtracting 10, we're going to add 10 to both sides of the equal sign. So add 10 here, add 10 there. So we have now 5 times x plus 2 squared equals 57. Okay. Then, instead of times 5, we're going to divide both sides by 5. So I need you to put divide both sides by 5 right here. And here. You're going to want to use your calculator for that, but I believe we now have x plus 2 quantity squared equals approximately 11.4, or exactly 11.4 actually. There's no other decimals. Okay, now here's the tricky part. So the inverse operation of squaring, let's add that to the table, is the square root. Okay? And that's called, that little shape I just drew is called a radical. So let's add that up here in our academic language. Radical sign. Radical man. Right? So, but one last thing here that we're thinking about, underneath the radical, or when you square something, it can be a positive and negative number, right? So if we have 6 squared equals 36. Also, negative 6 squared is 36. Right? So we have both a positive and a negative answer. So, luckily, what we've done, we take the square root of both sides. Okay? And when you take the square root of something being squared, it's just itself. So the square root of x plus 2 squared is x plus 2 equals, and then we can just leave this as the square root of 11.4. It's just a number. But what we need to do is we need to make this the absolute value, because whatever is being squared can be both positive and negative. Okay? So this can be both, and this is the cool part here, and I think you remember it from last year. This can be both positive and negative, right? So what we have is x plus 2 equals positive and negative the square root of 11.4. And you guys did the quadratic formula last year, so this should look familiar. Then our last step is subtracting 2 from both sides. Now, this looks crazy, but my answer is just going to be plus or minus the square root of 11.4 minus 2. So whatever this is positive minus 2 and whatever this is negative minus 2, just as if we are solving an absolute value like we did last time. Now I want to go back and check and see. So finish filling out this table. Okay, we took the square root of both sides, right? We took the square root, and then here the last thing is we subtracted 2, so fill this little table in. And then I just want to go back and explain this, which is taking the square root of something squared is itself. So what that means is, hold on. What that means is, okay, so what that means is if we go back to 6 squared, okay, and we take the square root of that, we just get 6. Because think about it. 6 squared is 36, right? The square root of 36 is just 6. What that does is that matches what we did up here. When we took the square root of x plus 2 squared, we just got x plus 2. You don't actually need to put these absolute value signs in here. I just wanted you to realize that our answer is going to be both positive and negative. So it is correct either way you do it. So let's do one practice problem with your partner, and I'll write that down for you. How about we do 4 times x plus 3 quantity squared plus 5 equals 10. Now remember, you will probably get 2 separate answers, a positive and a negative. So when you get there, if you need help, let me know. But just in case you need help getting started, I can write down the steps in order, and you're going to go backwards. We take a number, we add 3, then we square it, then we are multiplying by 4, and last we are adding 5. So you start at the bottom and work your way back up. What you do to one side of the equation, you do to the other. If you get to the undoing the squaring part and need help, call me over to check your answer. You may work with your partner on this.